Okay, we're talking about horizontal asymptotes, and you want to pay attention to what I say here right at the beginning because people get this confused and they don't understand asymptotes fully, which is understandable. Okay, when you're talking about a vertical asymptotes, does the graph ever touch a vertical asymptote? No. VA, vertical asymptote. They're very aggressive, okay? You cannot touch a vertical asymptote. Got it? They will like bite you, okay? They're very aggressive. That's why we put a little dotted line there, and it's like, I'm just putting a dotted line here. Don't get mad. And then you'd put the graph and you don't touch it, right? Horizontal asymptotes are not. And I don't have anything for HA. It's just like, ha, I can do whatever I want, you know? Okay, that'll work. All right, so horizontal asymptotes. You can go through a horizontal asymptote. You can go through a horizontal asymptote an infinite number of times if you want to, okay? So this top picture here is a horizontal asymptote at like this spot here, a little bit lower, but you get the idea. Okay, do you see how the graph is approaching that asymptote as it goes to the right forever? And it's approaching that asymptote as it goes to the left forever. That's actually the definition of a horizontal asymptote. It's what y value you're approaching as your x gets infinitely large positive and as your x gets infinitely large negative. So how many possible horizontal asymptotes can you have? Can you have 20 horizontal asymptotes? No, you can't. Can you have one? Yeah, can you have two? So let's look at the pictures down here. Okay, look at the first picture. Do you see how as we're going to the right, there's one value that's approaching, and as we go to the left, there's a different value you're approaching? So there's a total of two possible horizontal asymptotes. Your graph might not have any. Your graph might have one, but two is the maximum number of horizontal asymptotes. So the first graph here shows that you could be approaching different things as you go to the right and the left. The next one here is like a damped harmonic motion. You worked with those maybe in pre-calc. Okay, it goes up, down, and keeps getting closer and closer to the middle. What value is it approaching as you go to the right forever? 0. Okay, but do you see how we're crossing that horizontal asymptote an infinite number of times? Because it's just going to keep doing that. Even here, okay, the last picture, it crosses through here, but do you see how it's approaching 0 as we go to the right, and it's approaching 0 from the opposite side as we go to the left? So it just has one horizontal asymptote for that last one, okay? So looking at the top here, if you have your calculator, you can just put the function into your y equals, and then you can use your table. And a lot of people use their table here, and they get the values over here, and they go, okay, maybe I'm going by 1s or going by 2s. And you can get a pretty good idea here of what the y values are approaching. But why would you use really, really little numbers? And look what's happening as we're going to 6 if we can easily look at what we're getting to as we go to 300 or like 1,000,000 or something, right? If you have your calculator, you can start at 0, you can go by millions, and you can see what value the y is approaching as you go to the right and to the left really easily. So what does it look like we have for a horizontal asymptote as you go to the right and the left? 1. And if you look at the graph, it should support that, okay? But you can definitely go by larger increments rather than small increments and scroll for a long time. So as x grows larger and larger, positive or negative, so you have to make sure you look both ways, you can see the values of y, or f of x, get closer and closer to 1. So then we just say the limit as x approaches, and I would even switch this to plus or minus infinity. That's terrible. Plus or minus infinity are equal to 1, because both of those would equal 1 as we go to the right and to the left. Okay, and the line y equals L is called a horizontal asymptote if either of these is true. So as we go to the right, it equals L, or go to the left, it equals L. All right, this is a figure that's in your book. It's not in your notes, is it? Okay, it's up on the board here, so that helps it a little bit. It says find the infinite limits, limits at infinity, and asymptotes for the function f whose graph is shown. So let's just start with the new stuff that we just did. So let's take the limit as we go to infinity, and I think they called it f of x, but I'm not sure. We'll just call it that. And then let's find the limit as we approach negative infinity. And we're just using the graph to figure this out. We don't like have something to put into our y equals. So what does the graph look like it's approaching as I go infinitely large x values? 4. You see how the graph looks like it's going to 4 here? Okay, so we'll put 4. Okay, and what does it look like is happening as I go to the left? So you just follow the graph to the left forever. 2. Okay, so those would be our horizontal asymptotes. Okay, so you could write that our horizontal asymptotes are at, what would be an equation for a horizontal asymptote? X equals or y equals? Y equals. Okay, so it'd be y equals 4 and y equals 2. Okay, and then the other things it wants is where the graph actually shoots up to infinity or down to negative infinity. So where does that occur at? There's different spots. 2 we could go. Okay, so let's say we take the limit as we're going to 2. And let's say we go from the left. What's happening as I go to 2 from the left-hand side? Negative infinity, it's going down. Okay, and then go to 2 from the right-hand side. So as I'm approaching 2 from the right-hand side, what's happening to the graph? Positive infinity. What does that tell you then? If you're approaching 2 from the left and 2 from the right and it's going to infinity, so what does that tell you? It doesn't exist, so the limit doesn't exist, and it also tells you that there's what at that spot? A vertical asymptote at that spot. Okay, so we could say vertical asymptote, and what would be the equation for a vertical asymptote? X equals, because it's at that X spot. Okay, and there's one more vertical asymptote, which is where? Negative 1. So you can take the limit as you're approaching negative 1. Doesn't matter which side I'm going from. Both sides it goes to positive infinity, right? So we'll just leave it like that. We'll say if there's another one here then at negative 1. Okay, so some of the questions are going to ask you for the equations for the horizontal and vertical asymptote. Make sure you actually write an equation, not just a value there. Okay. So down here, we're actually trying to evaluate some limits. What you learn here, you're going to use a lot, so make sure you're asking questions if you have them. Okay, so let's do this one here. We're taking the limit as x goes to infinity, and we have 1 over x. So think about 1 over an infinitely large number. What's that going to? And it's infinitely large. Is it positive or negative? Positive. So we have a positive over a positive, so it should be positive, right? And it's just going to be positive infinity. So what would I want you to write on the AP test if it was for your response? Doesn't exist. You'd erase that and write doesn't exist. Okay. If we're going to negative infinity, oh, sorry, hold up. This is not right at all. Okay, if we're going to infinity, 1 over infinity. I'm just like listening instead of thinking here. What do you get if you take 1 over a huge, 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 huge number? A really, 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 really small number. And as that number in the denominator gets bigger, that number overall is getting smaller. What's it actually going to? It's not going to infinity. It's going to 0. Okay, now we're doing the same thing, but we're doing negative infinity. Okay, and if you need to use your calculator, you can, especially while you're getting used to these. Pretty soon they're going to be just like natural for you. Okay, we're doing 1 over a really, 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 really big negative number. Isn't it still going to be getting really, really small? It's going to be slightly negative, but what is it approaching? What's the limit going to? 0 again. Okay, now off to the right here, this is one where there's going to be something we'll learn in a later lesson that you could apply to these, but what we learn right now will kind of override that because this is better, okay? So when you're trying to evaluate the limit as we're approaching infinity. And you plug infinities in, don't you get an infinity thing on the top and an infinity thing on the bottom? So you can't do anything. Infinity over infinity, it's called an indeterminate form. You can't like do anything with that. You can't say, oh, they'll cancel and there'll be 1. Okay? The top infinity might be bigger than the bottom infinity, and then you end up with a value of some sort, or vice versa. So what you're going to do is you take the highest power in the denominator, and divide. Okay, so what's the highest power in the denominator? The squared part, right? So you're going to divide everything by x squared. You have to divide every piece by that. Okay, so I'm just going to rewrite it here. Okay, so 3x squared over x squared will just give me 3 minus 1 over x. And it's 2 over x squared. And then we've got our 5 plus 4 over x plus 1 over x squared. Okay, now if I go ahead and I plug infinity in, what's the 1 over x going to turn into? 0, right? 1 over infinity, 0. What's 2 over infinity squared? 0. So all of these pieces will turn into zeros. So what are we just left with then? 3/5. And it doesn't say it here, but wouldn't that be a horizontal asymptote? Because we're going to infinity, we approach 3/5, so that graph would have a horizontal asymptote at 3/5. So questions on that page, Shaw? Okay. Find the horizontal and vertical asymptotes of the graph. So how do I find the horizontal if it says find the horizontal? That's what the whole lesson's on here. We take the limit as we go to plus or minus infinity. So we'll take the limit as we go to infinity, and then we'll do the same thing as we go to negative infinity. We got to make sure we get, if we get the same thing, we just have 1. If we get different things, we have 2 of them. Okay, and here you'll learn something else that will be applied a lot. Okay, so I take the highest power, that's where? In the denominator. Because if I just try to plug in infinity, I have the same issue I had on the last page, right? So the highest power in the denominator is what? X, just x to the first. So I'm going to divide by x to the first, so I'm just going to write that here. And if you want to write a little 1 up there, you can. Now, x outside of here is equivalent to what underneath the square root? This confuses some people, so ask questions if you have questions. What under here is equivalent to x? If I have x squared, that's equivalent to x, okay? So when I divide by x to the first, but I'm working under that square root, you actually have to divide those things by x squared, okay, because those are equivalent to each other. Does that make sense? Ish. Okay, so I suppose I can get rid of my equals because I have some work in between here. Okay, so I'm going to divide everything in the top by x squared plus 1 over x squared. Everyone see where that came from? And everything in the bottom that's not under a square root, I just divide by x, so I get So what do I end up with for an answer here when I apply my x going to infinity? Square root of 2 over 3, right? Square root of 2 on top because these x pieces go away. Okay, so that's our first horizontal asymptote. How do I write the equation for that? Y equals square root of 2 over 3. Okay, we're going to do the same thing here, but we're going to negative infinity. Wouldn't the steps pretty much be the same here? Okay, and the only thing that with this that's weird, and I've never seen it on the AP test, so I just don't want you to freak out about it, okay? But if you get an answer and you look in the answer key and it's a negative and you had positive, this might be the reason why. Okay, when we're going to negative infinity here, the numerator, when it's squared, is going to be positive, right? What happens in the denominator if I plug in a negative infinity or a negative really big number? It's going to be what? Positive or negative? Negative. So when I get to the end, it should be approaching a negative value as I go to negative infinity, okay? The book explains it to be something with the square root, but I think that's way easier is just looking at it's a negative in the denominator. So when I do this second step here, I'm going to divide everything back squared under the square root, just like I did in the first one. And divide just by x here, but I need to have a negative out front of that because of the negative infinity. I forgot my negative there. So when I get my answer, it should be negative square root of 2 over 3. And if you look at the graph, if you put this into your y equals and you either look at the graph or table, it would support that. It's going to positive as you're going to the right, and it's going to negative as you're going to the left. Okay, so those are your horizontal asymptotes. How would we find a vertical asymptote? Because it says find horizontal and vertical. I'm not going to make you do the vertical here, but how would you do it? I like that if I don't make eye contact, I'm not going to get called on here. Lauren hasn't looked up yet. If you're given an equation, someone says, for $100, I'm not going to give you $100, but for $100, what's a vertical asymptote? What would you do? You just let them keep their money? The vertical asymptote happens when the denominator is 0, okay? Now, if you get 0 over 0, is there a vertical asymptote there? No. But isn't that a super easy $100? You just set 3x minus 5 equal to 0, and you solve a linear equation. That's how I'm going to get rich, you know? So where would our vertical asymptote happen? If this equals 0, you'd add the 5, divide by 3, so 5/3, okay? And if you had to show that there's a vertical asymptote there, all you'd do is you'd take the limit as you're approaching that 5/3, and you'd approach it from the right, and then you'd take the limit as you're approaching that 5/3, and you'd go from the left. And what should those go to? If there's vertical asymptotes at those spots that the graph does not want to touch, you know, infinity or negative infinity, right? So they would either go to a plus or a minus infinity there, okay? So like I said, we're not going to go over that. That was a different lesson. We'll keep going with this one. Okay, here I want to give you, I'm just going to give you just like a minute or two to try to do like 1 or 2 of these, okay? And then we're going to do them together. Okay, if anyone wants to look at this, you still can. There's lots of natural log and lots of E on the AP test, so we'll learn as we go. There's going to be a lot of it in the course, okay? We will, yep. Okay, so the very first one here, if you try to take this limit and you just plug in infinity, wouldn't you get like an infinity here minus an infinity there? Okay, so we get an infinity minus infinity, and some people say, okay, if I take something and I subtract the same thing, I get 0, because that's what happens with numbers. Okay, infinity is not a number. The first infinity could be 3 greater than the back infinity, or twice as much as the back infinity. So you have to be careful of going, oh, an infinity minus infinity is 0. What you're going to do is put this over 1, and then who thinks they might have an idea of what to do here? Sure. Ideas? I just did it today. Conjugate. Okay, so you'd multiply by the conjugate on top and bottom. Well, sometimes you just don't know where to go with problems. These are those type of problems where people just aren't sure where to go with them, so it's a bunch of all of them on one page. Okay, so, yep, it'll be on this and the last. Okay, so when I multiply here, okay, the numerator turns into x squared plus 1, and then minus x squared. What happens there? These cancel, right? So we just have 1 over that. Now can I put my infinity in? What do I get when I do 1 over infinity plus infinity? 1 over infinity goes to 0. Okay, so in this particular case, infinity minus infinity is 0. Happens sometimes. Okay, move to the right. If I plug infinity into the first one here, what do I get? Infinity cubed. Isn't that still infinity? Okay. What about if I plug negative infinity in and I cube it? Negative infinity. So for both of those, you can write does not exist, right? Okay, let's look below that one, the sine. What does the sine graph do as I go out to infinity? You don't know what the sine graph does? It just keeps doing the same thing over and over. What value is it approaching as you go to the right? What y value is it approaching? 1 and negative 1 and 0 and everything in between. So if it's not approaching one value, it does not exist. Okay, it's oscillating, so it does not exist. Okay, it has to approach one singular value as it goes out to the right. All right, let's do this one here. This says 0 from the left, doesn't it? Okay, let's just focus on the exponent. So as we're approaching 0 from the left, what is 1 over 0 from the left? What does that mean? A small negative. So if I've got 1 over a small negative, what do I get? We get a negative infinity. Okay, so I'm just going to replace this with a negative infinity. So it's like I have an e to the negative infinity. When you have a negative exponent, what's a trick you can do with it? Put it in the denominator. So if we put it in the denominator, we got 1 over e to the infinity. E is like 2.7 something. So if you have 2.7 something to the infinite power, isn't it just infinity there? So 1 over infinity is 0. We're about a week behind because we've been going so slow. Yeah. If you want to come up during the day sometime, though, you can, okay? Yeah, already. I know.
This is small.
Yep. Okay, let's take a look at this here. We're going to infinity. Wouldn't you get infinity minus infinity again? Okay, ideas on where to go with this? What do they both have in common? Pull out an x. If you pull out an x, you have x times x minus 1. Now if we plug in infinity, what do we get? Infinity times infinity. Isn't that for sure infinitely large? So this would be infinity. So again, you could write does not exist. Well, infinity minus 1 is still infinitely large. You know, infinity just keeps going, so. Yeah. Not a, well, if the answer is infinity or negative infinity. Now the last one here, this is one we just learned today. Okay, divide everything by the highest power in the denominator and the answer falls out of it. Okay, so this piece here, we would get x plus 1 over 3 over x minus 1. So we have infinity on top, and this turns into 0 minus 1. So what's that going to turn into if we have infinity over negative 1? Negative infinity, so we could write does not exist again, okay? Okay, if you need to come check answers later today or come up and work, that's fine, okay? There's your homework.